So the ideal gas law incorporates all of the different variables that we've talked about for gases up to this point. For my example, I've got over here, if 2 moles of hydrogen is stored at room temperature in 27 liters, what pressure is the gas going to be at? So the best thing you can do for an ideal gas law problem when you start out is take all of the variables and write out what you already know. So our formula is PV equals nRT. So from the problem, I'm going to take the first part. I have 2 moles. So my small n here, or moles, is 2 moles. The rest of the information that I know is that it is stored at room temperature. Down here for temperature, we're going to say room temperature is 23 Celsius. But we're not going to leave it as Celsius. So when we're dealing with the gas law problems, almost always you're going to be converting to Kelvin. So 23 plus 273, that's our Kelvin conversion, gives us our 296 K. The rest of the information I have is 27 liters, and R is our gas constant. So in this case, I'm dealing with 0.082 because we're dealing with units that are in liters. We'll end up with an answer, hopefully, in atmospheres, if we do everything right. We're dealing with a gas quantity in moles, and we're dealing with a temperature in Kelvin. So once I have all of this information, I'm just going to start plugging them into the formula in the right spots. So I've got P as my variable that I'm looking for, 27 liters. As my volume, I've got 2 moles. I've got my gas constant, 0.082 liters, atmospheres, moles. Kelvin is the units on the gas constant. And then for my last variable, I've got 296. Okay. So to start to solve this problem, I'm just going to start on the right side, and I'm going to start multiplying together my gas units that I have, the gas constant, and I'm going to multiply that against the 296K. And that will give me 24.27. I've got Kelvin on the bottom, and I've got Kelvin on the top, so that will cancel out my Kelvins. And I'm left with liters, atmospheres, and moles. Once I take the 2 moles times this 24.27, I'm going to end up with 48.54. And that's now just going to be in units of liters and atmospheres, because I've got a moles on the top and a moles on the bottom, and that cancels out my moles. So now I've got this question mark for my pressure. I've got my 27 liters, and that's equal to 48.54 liters atmospheres. So to get the question mark by itself, I'm going to divide both sides by my 27 liters. I do that to one side, I have to do that to the other side. 27 liters cancels out to 27 liters. I'm left with just my question mark, which is my pressure. On this side, the liters on top and the liters on the bottom will cancel out, so I'll be left with just my atmospheres. And once you take the 48.54 and you divide by the 27, you'll get your final pressure as 1.8 atmospheres. And that's the ideal gas law.